Hey everybody, happy Tuesday. Hope y'all are having a great day. I am Brandon and my hair's blue. Look at that. It actually happened. I have dark hair, so maybe not a light cyan, but here we are. So, welcome back to the stream. I have got a big Tuesday planned. If you were here on the stream last Tuesday, we spent some time actually messing with, let me go back into this, 1 second, with this wonderful little contraption over here, the Brew Buddy. I shared last week that this was the early iteration of the Brew Buddy, particle photon-based homebrew monitoring solution. And what we did on the stream last week was actually spend some time going through upgrading it to some new hardware. So to actually upgrade it to the Particle Argon. So hence all of the wonderful jumper wires. We have a prototype on the breadboard that's working and that is coming together. So now it's actually time to create a custom PCB, and that's what the process today is going to look like. So what we're going to do today is actually get into a computer-aided design PCB design tool called Eagle, which I'm really excited about using. I use Eagle a lot on a regular basis, and so we're going to take this existing design and we're going to use Eagle to lay out a brand new board, first with the schematic, then with the actual board layout itself, and then we'll spin those new boards on Ocean. We'll actually order them from an online fulfillment service here in a little bit. So should be good fun. Should keep us relatively busy for the next couple hours. But thanks again for joining. If you're here in chat, feel free to say hello. Otherwise, feel free to keep on hanging out and lurking. And let me check something really quick on my stream report. See what's going on. Oh, now it said it's okay. All right. Going back over. How to switch. Oh. Stream Deck did not quit. What's happening? No. No, it didn't. Okay. All right. So like I mentioned, this is Eagle. And Eagle, there are really two pieces relevant to my project here. On the left-hand side, hey Babbitt, welcome, hello. Good to see you. Thanks for jumping back in today. We're going to do some PCB layout today in Eagle. And again, like I have to have the sound for this because Eagle's great. Eagle is a AutoCAD product. There is I think there's still a free version of it available, maybe. I have an educator's version that I've had for a couple of years and use it for some of my side projects as well. There are a lot of great PCB CAD tools out there. Eagle, there's KiCad, however you pronounce it. There are a number of others out there. There's Altium, the big expensive version, have never used. But Eagle's come a long way in the course of the last couple of years, and so I'm excited to walk through it and use it today. So there's two main pieces to actually working with a layout in Eagle. There is the schematic design, which is what's on the left-hand side here, and you'll see from the original. And Eagle changed some of their zoom functionality, and they're updating it a lot, which is great. There we go. I'm going to zoom out a little bit more so I can show you. Let me move to my head. My giant head is in the way. So let me just move it over so you can see it, and I'll go back to zoom to fit. The schematic is sort of your actual logical design or your logical illustration for the board itself. So the main pieces that I have here in the older version of the board were the particle photon, the main in the center, the 2.2 inch TFT, and then the thermocouple, the Type K thermocouple, the Max 31855K. We still have those on the board. The one thing that we added last Tuesday was the knock sensor. We added the little thin piezo to function as the knock sensor when fermentation is detected. So we're going to add that in here as well. But the first thing that we got to do is swap out this photon for an argon, not an argon, xenon. Same pinout. In fact, did I do it? Hold on, I may be wrong. Oh yeah, it is an argon. It is an argon. It's a Wi-Fi. Argon is the Wi-Fi board. I knew that, but I just couldn't remember which one I actually used in this design. So that's what we're going to add. Now, there's a few different things here. Because the new devices use the feather form factor, it's actually possible for me to use some different variants on that layout. So one of the things that I did, and I'll open up a different project here, I created a badge last year called the Party Badge. Let me see if I can open it here. This is the final version. Yeah, I'll open this one up. So Eagle's gonna open up. We created late last year a version of the Party Badge. There are a few different iterations, one that used the photon and then a few others as well. This iteration actually used the xenon in all of these and used the new feather footprint, right? So we actually have a particle mesh with SMT headers. So this is actually a nice surface mount little package here that I can use that also has pins on both sides. So that's ultimately what I'm going to do. I'm going to use that surface mount design because I like it, because it's good fun to use. And so I just needed to make sure that I knew exactly where it was. And then zoom out here. And y'all forgive me if I get a little keyboard slow today. I actually got a new keyboard over the weekend, so I'm figuring it out. Okay, where's my head? This is the piece. Okay. So the package here, excuse me. SMT Dual is the one that I'm going to be looking for, so that's what I'm going to swap out with when I get over to the new project. So let me go back to where I was. Eagle's already released 9.3.1. Cool. We're not going to update that right now. You open up my board in schematic again. So there's a tool here. Typically when you add a new item, you add a part, you can click on the Add Part button and swap things out, search for parts, etc. Right? So here's my particle mesh library for Featherwing. I can get SMD Dual is the one I was looking for. That has the right package. I can add that. I can just go ahead and add it manually. And then put that anywhere on here. Right click to rotate. The other option is to swap. I don't know if I want to swap or not, because I might actually end up wishing that I did. So there's an option to replace an item on a schematic. So let me find that one. These things get changed around here sometimes. There's a replace. There it is, replace. So I can actually click here, grab my footprint, and you'll notice if you've not used Eagle before that in the schematic view, as you're looking at packages, you actually get both the schematic view and the physical board view. This has been really handy for me. There's been many times that there's a lot of packages in here. There's a whole lot of stuff. I don't even have a ton of libraries included. There's a lot of stuff that Eagle ships with, and there's other libraries out there that you can include for different kinds of devices. And so it's nice to know what you're going to be getting in the physical layout as well, in addition to what shows up in the schematic. So I clicked replace. I should be able to now click on the photon. Oh yeah, so it's a mapping. A5 in the old version of the symbol photon can't be mapped to any pin in the new version of the symbol. Okay, that's all right. I'll just go with the, I'll just go with adding it. Where's my target here? Boom. It's in. It's on. I'm gonna zoom out a little bit. Oh, that's too much. I don't want to zoom out that much. All right, you're gonna be that way. I'm gonna make the screen a little bit larger here. Let's just stick with schematic view all the way across. And then I'll move this, find my target here. Oh wait. Select the move option and move this over. All right, and so now it's going to be a matter of just rewiring the right things into the right places, or rerouting things on the schematic side. But you'll notice actually when I update the schematic that I can go over to my board view and this item is here now. The package is actually here. It's been added. Waiting for me to actually put it on the physical dimension layer somewhere. I'm not going to do that yet because I'm going to do the routing. Create my wires properly here. And then I think I'm going to clean all this stuff up. So I'm going to rip up. Actually, rip up is on the board layout. I'm going to just clean out these references. I added some things in there. Really better if I just remove, and I'm going to remove the photon footprint as well. So I'm just going to go through and start clicking with abandon. Mohit, hey, yes, it is. It is, as promised. I have dark hair, so maybe it doesn't look super cyan, but close enough, right? All right. So I created this layout, or I created this this PCB a couple of years ago. There's a few different general things that I've thought about the design here, and maybe I'll just keep this open. This original version of the board, other than actually having the argon in there and the TFT, not the TFT, the thermocouple, I don't think that I need to have the TFT actually in via headers. I think I'm actually going to do more of a ribbon connector on that, so I don't need to worry too much about the size of the TFT when it comes to actually going and doing the layout moving forward. So that should be good. Looks really good. Should be my permanent look. You know, actually, I do kind of dig it. It's working, so maybe it will be. Maybe it will be. It'd be kind of fun. I lost my mouse again. Okay. Ah, no. I accidentally delete stuff all the time. Thankfully, there's always undo. All right. Move this more towards the center. And then I'm gonna, nope. Cyan beard would be fire. It would certainly be something. It would certainly be something. And then I'll move my thermocouple up. Where's the target? Okay. And it just occurred to me. Well, I can decide on the orientation of this. That's fine. I was realizing that I don't have this TFT. This package is just allowing me to put headers in the top of the board. And I've sort of, I think last time I had decided, you know, the numbers are arbitrary, so I think I had decided last time what was 1 and what was 10. So I need to do that again, but that's not a big deal. Okay. Give myself some space here for now. And I'm gonna be sliding over and taking a look at the board a lot so that I can figure out kind of where things are gonna go. But I do know that on the thermocouple, let's see. I can at least figure that piece out by taking a look at how it's in today. So my ground, all right. So I'm actually gonna use the create nets for all these, and then I'm gonna name them. So I'm not gonna have a bunch of virtual wires going all over the place. And then, are these all connected? All right. So I'm gonna name this net ground. Yep. So what I'm doing here over the next couple of minutes is, instead of dragging wires like you saw here originally, I'm just going to use named nets to keep this a little bit cleaner. That was something that I didn't do a couple of years ago and since learned over the course of the last year or so. So we got ground, VCC, SEK, SO, NC, and CS. So this is going to be VCC. SEK. SO. Ow! That's not good. Silly and move it. Okay. Okay. NC. And finally, CS. So now it's a matter of creating the same names on the other side, in which case, at which point, let's see, I will actually get my code window up here so that I make sure I get my pin mappings correct. So let me make this a little bit smaller. And I'll bring this down so I can at least see. There we go. See the code. All right. This footprint doesn't have D2 through D4 labeled. Hey, Joe. Welcome, welcome. So SDA, SCL, D2 through D8. So the one I'm looking for is D4. 1, 2, 3, 4, 5. From the bottom is my chip select pin. Oh. All right, that's going to be my CS. So I'll add the net, place the label, connect in with CS. So now the nice part about that is if I click on the show icon here in the upper right hand corner and then click on CS, it'll actually highlight the CS down here, you can see it in sort of a lighter green. So it shows that those two are indeed electrically connected, which is what I wanted. So that's the first one. The next one is what I'm setting is VCC and ground. So D2 and D3. Did I do that? So S0, 1, 2. Oh yeah. So let me do 2 more. Oh no, D3 and D5. For that, D3, 4, and 5. Okay, so D3 will serve as my ground for purposes of the thermocouple. Like I gotta have the lines out. Cover under the naming all the way. So that D5 then is VCC for the thermocouple. Let's check those. Okay. CS, okay. And okay. So those are connected. SCK, Miso, and Mosi are on 6 through 8. So those represent the other pins. And I'm gonna pull this thing over here so I can look at it more closely. Oh, I'll leave it there. I'll leave it there and take a closer look. Just want to verify. Third one down. Yeah. This is the manual part. SCK should be going to, just SCK, right? So 1, 2, 3, 4, 1, 2, 6 on the bottom. And this is the kind of thing that you want to be super duper careful and cautious about. And I'm not. I'm usually not. I usually do something boneheaded in this. I can't think of a single time I've ever only had to order boards one time. Maybe this will be the first, but I'm not holding my breath. Okay. Yeah, that's the one. .commie. Hey, welcome. That is the one. I'm being like super. It is right, but I'm like double and triple checking myself to make sure that I don't get it wrong. I need to probably update this footprint so it has, instead of GPIOs, it has the actual, in this case, the digital pin mappings. But yes, that's correct. And then SO and NC should be, let me double check how I have those wired. Array wire over here is going to Miso. Okay, so that makes this NC. I'm going to change the names of these. I'm going to change the name of this one to... So they're actually... Yes, I did. I deployed my new hair color just today. What do you think? How does it look? Make sure this smells. I'm actually going to go with the names on the Argon here, not the names on these SONC names I was using before. Are actually the names on the thermocouple on the breakout board, but I don't need to do that. Let's see me so. There we go. Great. Connected. Yay, yay. Nine AM, very blue. It is very blue. Yeah. Maybe slightly bluer than I expected. But that's all right. Okay. So I have all 6 pins there, or 6 pads, appropriately represented here on the schematic. So now it's time to mess with this TFT, which should be good fun. So I have a few common pieces here on the TFT. I am also using the A6 through A8, but then I'm using, for chip select is A2, A1, and reset is A0. Apollo 7, particle blue. Yes, absolutely. Hopefully it's kind of close-ish that I could get to it. Maybe not totally, but it's at least blue. All right. What did I do here on that? Yeah. Ocean blue. Ocean blue. I like that. Not the ocean in Texas, in the Gulf of Mexico. That water is not blue. Maybe in Florida, California. Thanks, Kami. I appreciate it. I had a friend who commented earlier in the stream and said that I should make it my look from here on out. Maybe I should. Yeah. I kind of dig it. Okay. Yeah, A0, A1, and A2 are the pins that I'm using here for TFT CS. So here the question is, and if it seems like I'm like overthinking this, it's based on many years of, not many years. It's based on more than a few times of messing this up and having to reorder boards because I inverted something that I didn't need to. So I've got those connected. So here for the TFT, what I want to make sure of is that I get the orientation. I mean, the orientation ultimately doesn't matter, but I need to at least have them consistent with the pads. 0 to 10. So hold on. Yeah, all right. I thought that was right. So I treated this pin as my ground before. So let's start with that and actually make sure it connects this appropriately. Got to get back to work, but I love your streams. Makes me want to try a bigger project. Thanks for streaming. Oh, thanks, Apollo 7. I appreciate that so much. And definitely. And if you ever have any questions, send me a whisper on Twitch or hit me up on Twitter. Definitely happy to help, and enjoy the rest of your workday. Thanks for jumping in. I really appreciate that. All right, I'm gonna rename my grounds here. So y'all, again, forgive me as I'm actually gonna call this, yeah. TC ground, because it's for the thermocouple. And now I have to like, I gotta do this cleanup piece. I had the advantage last year after I joined Particle. I mentioned that I worked on the badge, the party badge, on a few iterations of that, and I actually had some help from some of the awesome engineers, firmware and hardware engineers that we have at Particle, and I learned a ton from those folks. One of the things that I learned is to be a little bit more particular about schematic layout, board layout, all that kind of stuff. These resources that hardware engineers spend a lot of time on. Oh my gosh. Now come on. There we go. So y'all please forgive me if maybe I should just, all right. I thought I had it. I'll come back to it later. Because these need to get dragged out too. All right, I'm gonna let myself let it be for a few minutes, and then I'll come back to it later. Because what I wanted to do is change that so that this could be proper ground. And then this net here, and I'll drag that out since I know that I'm gonna need it to line up with everything else. To be ground. So those are connected now. Oh, okay. All right. See, so now I know. Notice here, that's actually not what I wanted. This is why I'm doing this, to make sure that I had this correct. I want little number 1 here, this to be actual number 1 to be ground, not number 10. So good. Fix. Remove. But that helps me establish this is the baseline. There we go. All right, we can handle that. I said I wasn't going to worry about it. I can't help it. I just don't like it. See, now these look sort of comically large, so. Dragging them out. Ugh. It's all right. It's all right. So then once I am done with this, I am going to, so I'm done being crazy. I'm trying to make everything look just so. I'm going to wire up the rest of this. So 1 was ground. We have VN, DC, reset. So we know what the VN is. So this is next. So I'm gonna just net this and then call it 3v3. And do the same here. So now those two will be connected. Yay, yay. Make absolutely certain that's right. Yeah. Two down, 8 to go. Next is DC, the data channel, and data channel is on, that's A0, so I can go back over to my code view and see what I'm doing here. DC, I'm in DC and A0. Hold on. DC on A1, which just like it says in the code, but can't be too careful. Gotta look, gotta look. What program are you using for schematics, PCB designs? Good question, Kami. So this is Eagle, Autodesk Eagle. You can, oh wait, I gotta use the sound every time I say Eagle. Yes, Autodesk Eagle. Eagle's been around for a long time. Autodesk purchased it a few years ago. Good CAD tool. I like it. It's actually what, a lot of folks that use it. KiCad is another great one. It does have some cool features, and they've made a ton of progress with it over the course of the last year or so, especially. But definitely go check it out. It has cross-platform support, Windows, Mac, Linux. Good tool. So that is what I am using. That's what I'm using for the design and layout. All right, so reset's going to go to a 0. Sorry, let's just do this. Save myself a minute. I'll create nets here for these next three. A0, A1, A2. Is there a hobbyist version? There used to be. I think there still is, but I don't know for certain. It used to be that there was a hobbyist version, and then you could only use it if you're, as long as your PCB was under a certain size. Is that right? Or maybe it was only if it was open source, like if you weren't going to try to commercialize it. I'm not certain in that regard. But definitely check it out. I actually use an educator version because I use it for my side business, the Carapan Studios. We do books and electronic kits for kids, for educators, and so I use it primarily for that. Also use it for the day job. So I have an educator's link, or an educator's version of it. That's another option too, if that's your thing. There's a free version, but it has limits from what I understand. But yeah, size restricted and the number of elements you have. Thanks, Babin. I appreciate it. Appreciate that. And then yeah, thank you, David. There actually is a student version that you can check out as well, which is cool. And there's some great videos. Failing that, there are some complete free open. One good reason to keep that edu email around. I wish I had. I wish I had for sure. And then there's KiCad, KiCad. I'm going to just say both pronunciations. But if you ever want one that is completely free, you can go to check out. Oh, cool. And there's monthly rates. Yeah, because Autodesk is on the SaaS subscription model. So if you go to KiCad-pcb.org, there's another one as well. I have used both of these in the past. I like them both. I think they have pros and cons. KiCad went up to version 5 last year, and it apparently got a ton better. Like, people seem to be really happy with the latest version. I haven't personally used it yet, but there's some good courses and tutorials for both of these as well. And then there's others, but those are the only two. Those are the only two tools that I have used. Okay, we got A0, A1, A2, but yeah, good question, Kami. Thanks for asking. And secretly, honestly, the reason that I use Eagle is because I can play sound for it. That's it. That's 99.9% of it. And that's why David, DC Shelt, that's why he likes Eagle too, because, you know, keyboard emojis for it. You know that's right, David. All right, A0 is mapped to, so let's name these nets real quick. A0 is on reset. A1 is on DC data channel, and A2 is on my chip select for the TFT. So let's actually, I'm gonna rename these properly. And of course, this is gonna mess up my spacing for everything. Yeah, although I can't find an eagle emoji in Twitch. What? You know what? I have some other emote slots open under my account. Maybe I need to create an eagle emote. An eagle with the cyan hair, like the trash panda. We could totally do it. We would totally do it. Oh, I'm so annoyed. This is one of those, like, I'll fix the nets later. That would be a good use of this space. Indeed. Indeed. Okay. So now, let me figure out where my, oh yeah, so it's data channel, then reset. Those are my next two. So this would be my, let me just create nets for all of these. All of these tools have their quirks. They've been around for a long time. Eagle's been around for a long, long time. But the Autodesk team has been just killing it in the last year or so, just releasing updates and improving the state of things. There's a mechanical design like 3D viewer I'll show in just a minute that actually wire into the other tools. So you can use Eagle with Fusion 360 to create like enclosures and create milling jobs and things like that. It's pretty sweet. Check it again. DC. See, I was about to do reset on the next pin and it's DC. So this is going to be TFT top DC. Next is reset. Okay. TFT reset. So that must make this one, maybe? Let's see what's next. TFT reset, because I don't. It's SD chip select, then chip select for the TFT. So CS, we got to come back to that one. 5 here is the chip select for the SD card. Which I might as well create a net for. Great. Okay. So after those two chip select pins, MOSI, MISO, SCK, and backlight, which I am not using. this one is also going to be on MOSI. So we're already connected up. So SCK. And this one is actually not connected, so I'm going to remove it. This is actually an area where KiCad over Eagle has the way to actually specify that a net is no connect with a little red X, which is nice. Eagle doesn't have that by default, or at least they didn't as of like version 9.3. Maybe they added it yesterday, but it's not there right this second. MOSI, MISO, SCK. Okay. So that's everything on the existing components. But before I get into any of the layout madness, let's add the piezo. So the piezo right now is wired up to, what did I set that as? A4. Right. Oh yes, it's piezo and a 1 mega ohm resistor, which I'm going to do as a surface mount package. So let's add that first. So search for 1206. Let's search for some 1206 resistors. 10 ohm. Generic resistor package. Resistor 1206. Okay. If you haven't done SMD work before, 1206 refers to the size of the package. Width times height. You can sometimes hear people who refer to 0804s or 0402s. I am not a young man, and so I can hand solder 1206s and even potentially smaller ones, but I might as well use. Oh, fine. I'm gonna talk to myself. I'm gonna use 08. I'll use 0806. Where's 804? What did I say? No. 0806. There's another here. All right, now I'm confusing myself. So I'm just gonna stick with that. All right, so this is going to be my, and let's see, where is that one? It's on A4, right? Thank you, Babbitt. Oh, yep, 0805. See, I have not slept well in a couple of weeks. That's not it, not an array. But thank you, Babbitt. You saved my tail on Saturday night, and you're saving my tail again here. Much appreciated. 0805, 0604, 0402, 0403, 0201. Doesn't matter. Anyway, smaller and smaller. They get progressively smaller and smaller. 0805s, I don't mind. I can hand solder some 0805s. They're fine. All right, so this is going to be R1. Also learned the hard way that imperial and metric exist as well. Oh, yes, they do. They absolutely do exist. And it's not fun. I mean, I can't define the user definable value. I think I used the 1 mega ohm resistor for this. Yeah, I did. All right, now let's actually see what piezo packages look like. Yeah, see, all right, so ultimately, this is not going to be soldered into the board. I'm going to have two wires that basically get soldered into the board, and the two wires will go into the appropriate places so that I need some length on the piezo because it's going to sit on top of the carboy to serve as the knock sensor. So it needs to have, you know, a couple of feet of wire that are going to be running out of it. So I'm not going to do a piezo specifically. I think what I want is a what's the word I'm looking for? I mean, I want to, yeah, connector. Yeah, this could work. 1x2 connector. So this is just a generic header pin footprint. So you can see some basic, you know, some differences between kinds of things you would get in terms of footprint. Molex, no. Long pads, doesn't matter. Spring terminal, no. I could do like a screw terminal. Screw terminals on spark plug. Let me see if this is what I think it is. I mean, that's the more sustainable way to do this. What's that one? 2.5 millimeter pitch. Because ultimately, that way, if I get the wire length incorrect, I can come back later and lengthen it. And that's kind of a nice, sustainable thing to do. Sustainable. Let's call it that. So yeah, let's do the screw terminal with 2.5 millimeter spacing. Or, let me look at the prices on these. To make sure I'm not signing myself up to put something in the layout that's going to be like way more expensive. Oh, no, those are good. The 2 pins are 75 cents. Okay. All right. Done and done. So I'm going to rename this, and this is going to be, we're going to give it a name of knock sensor. And there's two things I got to decide now. One is how I'm arbitrarily just assigning these pins, but I'm going to need to mark it on the silk screen so that I don't mess up later. And then the other is to figure out what I'm doing with my resistor. Oh, right. Hold on a second. I need some light on this. A4. Oh, right. Now I remember from last Tuesday. The resistor is actually, yeah. Now I remember. The resistor is actually across both terminals. All right, come on. So let me add that. And let's make number 1 go to ground. Yeah, let's do this. I have a plan. This thing will let me rotate it. There we go. This is me being silly again, I know. Not that. All right. What did I say? We'd send 1 to ground? Sure. Okay. Shorten this up now. And then we put the knock sensor on A4. Yeah, knock pin A4. So let's call this one knock. Okay. And knock goes on the other side. So we'll do another net here, and that should actually do it. Oh yeah, gotta do a net on A4. Slide the rest of these out. Okay, so let me check everything. UV3, connected, ground, TFT reset, TFT DC, chip select, knock, SCK, both sides, MISO, MOSI, both sides, MISO, both sides, ACC here, chip select. Let's call this one, for the sake of clarity, let's call this one TC chip select. We're getting there. All right. Okay, so now what I want to do is run an electrical rule check, and this will just run through very quickly and see if I have any issues. Let me see here, unconnected input pin. No, that's all right. Prove that. Only one pin on net SDCS. Ah! This is why you run these things. I don't have the SD chip select actually going anywhere right now. Thank you. TFT has no value. 5-pin 3-volt overwritten with 3v3. No, that's okay. USB without net, it's okay. VBAT without net, don't need it. But I'll do those two. Cool. All right, so a few more things to clean up here. Should be good to go. Value. Set that. Here, I'll set this back to JP1. All right. So far, so good. Let me run that again. I should only have my one issue of SD chip select, which is fine. And what did I decide to set that to? D2. D2, right? So D3 was around here. Okay, so I can add a net here. Add a name, and we'll say SDCS. Run my ERC and nothing popped up, so everything is good to go. And we have ourselves a new layout, our new schematic that includes the NOx sensor, which is great. So we get some, we have some things we can do now. So now we can actually switch over exclusively to the layout view and do a couple of things here. I'm going to actually remove some references here. I no longer have a photon here, so that can come off. And then show real quick. I mentioned earlier, here, let me switch just to the main view so you can see it. Eagle actually has a pretty cool manufacturing view that they've added recently. Which is kind of nice. So you can actually get a view of what the board will look like in reality. And you can add you view the top side, you view the bottom side, look at the drills. You can actually set your colors on here as well. Background copper, so you can get sort of a bit of an idea of what things are going to look like when you go out and manufacture it, which is pretty cool. So we'll look at that a couple of times just to see what's going on. But I actually want to remove some of my dimensions here. In Eagle, one of the things that sets the actual size of the board is a series of wires that function as dimension layers, right? Or lines that functions as dimension layers. And so I'm going to remove those so that we can start over again and create a different board. And I'm going to go for small, because the smaller the board, the cheaper it is. And that's usually the order. It's usually how you want to do it. I have some like plated holes in here and stuff that I'm not going to need if I'm not worried about if TFT is going to be ribbon connected as opposed to physically connected. Okay, decide what I want to do with those holes, and then holes at the edges. So I'm going to move the holes out of the way so that they can. I will bring these back in. So I had a 3D printed enclosure for this before, and I'll probably bring that back around. Featherwing. Yeah. So the Argons, all the new devices, the Particle Argon, Boron, and Xenon are all Featherwing. I'll use the Featherwing form factor. So they're pretty nice to consistently work with like that. This particular footprint that I'm using is an SMD. It's a surface mount footprint, so I'll have to keep that in mind if I'm going to route anything underneath, but frankly this is not going to be too complex, so I'm not too terribly worried about it. But what I want to do is I'm going to position this kind of in the center here. Let's zoom in a bit. All right, so here's one obvious sort of opportunity right now is that I can move, I'll put the knock sensor over here. Let me zoom in there a little bit. Oh, this is going to be the outside though. Here, hold on. Come on. There we go. We want that on the outside. Sort of toward the edge of the board. What I'm doing to rotate these parts is I have the move tool selected here. And I'm just selecting them and then I'm right clicking. Although it's not. It's being finicky today. I just want you to rotate. I just want you to, don't make me choose the tool. Fine. All right, there we go. So now I have things a little bit more cleanly mapped here. It looks, so the yellow wires right now are just air wires. These are not the real representations of, here, let me make this a little bit smaller. Slide this over here so that the chat is not in the way at all. But also not my big old noggin. Yeah, that'll work. Okay. These yellow wires are actually just, they're called air wires. They're just sort of virtual representations to tell me what it is I actually need to wire to. But it does help me before I start routing things, which can be kind of a pain to rip up and move. It does give me a little bit of an idea of where this board is connected. Or where the individual pads are going to be connected so that I can plan accordingly. So I think I'm going to put, for now, I'm going to put my TFT connector up here. And then once you do this, the air wires sort of give you a bit more of a guide. Is there's a button you can hit. Where's the rat's nest button? Then move it. Okay. This button, rat's nest, which will sort of reroute things once you move things around so that you have the fastest path. Because when you move these and then click rat's nest, it's going to kind of give you a bit of a guideline for how to route. It's not the end all be all, but it does at least give you a visual indicator of where things should be placed. So that, click rat's nest again. And then my thermocouple is going to be on the other side of the board. So the way that this is going to end up looking right now is I will have the rat's nest again. I'll have my argon in the center of the board. I'll have the knock sensor 2-pin connector on the left side, thermocouple on the right side, and then the ribbon connector for the TFT on the top. And I think that kind of works. And then these things need to be sort of enclosed into the board. The thermocouple right now, because I'm using the breakout board, will need to be faced the way that it's facing in order to face out. So I can't rotate it. It needs to sort of stay put. I can move it. I'm gonna move it down. And I'm gonna move this stuff out of the way. As well as all this stuff. Just moving some things around. I'm gonna move that there. Okay. And I want, okay, so I need to actually create a, how's that gonna show up? I need to remind myself, so if y'all are still with me, remind me. I want to very clearly indicate here where ground and chip select is, or ground and the actual knock pin is. This will be obvious because there's only one way it's going to go in, although it probably doesn't hurt for me to do the same thing on the outline there. So I'll come back to that, and then this will be ground on the top here. All right, let's do some routing. So in order to do that, I'm going to choose the route tool, and then you can choose the layer. Let's see if my width is. Quick route, yeah. You have a number of different layers. The important pieces here for a 2-layer board like this are top and bottom. I think I'm going to keep pretty much everything here should be on the top. But the more complicated the boards get, the more you can actually do with 4-layer boards. Have different layers, and it's kind of nuts. So let's just do just actually start routing some things. And so all you do is just click on a pad, click there to terminate it. Same thing over here. I will. There we go. Width on those. Huh. That's all right, simple board. So same thing here with the knock sensor. I will just come down here. Route it out. And then they'll just sort of keep hitting rat's nest over and over again. It'll sometimes kind of update on me, change a little bit. Those two are routed. You'll see the names. When you get close in, it'll show you the signal names. I don't like that. Okay. Clean these things up a little bit. If you have any thinking that you're going to use, since this is actually a 2-port, the way that this SMD Featherwing header works is I'll plug the Argon in, and then I can actually access the pins on the outsides as well for other things. Prototyping is sort of a nice thing. The Adafruit, their little bot platform thing, the Cricket has the similar sort of header in there for Featherwings, so I like using that. But you'll want to actually connect these as well if you're going to do that. Make sure your signals between these pads are also connected on the surface mount. And it will add air wires to these, so you'll get a warning if you don't do this. We can go ahead and do that now to get some air wires out of the way. All right, rat's nest again. through here as well. All right. All right. So I think what I'm going to do now is actually wire up. There's some obvious ones here that I can wire up. So chip select on the thermocouple, and then these two, anytime you see air wires that are crossing here, or in the case here, it's usually an opportunity. That typically means that you're not going to necessarily be able to follow the most direct path. So we'll address those here in just a minute. And actually the same thing here with TC ground. So for the thermocouple, I'll notice that I'm actually going to have a couple of collisions here potentially. So what I can do is I'll actually create a via and then bring this up on the other side. So what I can do is I'll click route and actually go to the bottom of the board in this case, because these are through-hole components. I can actually start any of these on the top or the bottom. But for TC ground, what I'll do is I'll come around, I'll come out this way and come down about here, and then I will choose the via. It's a big old via. Still big. Yeah. Didn't like that. Go even smaller. Just do not. I'm still getting like the same diameter, but very small. Did they change the way that vias work here? Oh, give me auto diameter. Dev chatter, hey everybody, welcome. I don't know, my raid alert didn't show up, but that's crazy. Anyway, dev chatter, welcome, welcome, welcome. Hey Bredonius, hey folks. Thanks for coming and hanging out. We're doing something a little bit unique today. I'm actually working on a custom PCB for this homebrewing project here. Turn the light off. Come on, light. Off. This is the Brew Buddy, so it's actually something. Hi Rick Law Codes, hey there, Stu Penner, welcome, welcome. Yeah, so I created this project a couple of years ago. I'm modernizing it, putting it on some new hardware. Last week we did a little bit of actually messing with the firmware for this, and now I'm actually doing a custom layout right now. And Babin, I missed your comment. I really appreciate you going through the thought process about what you're seeing and how you think about it. I only ever auto route because I've done simple things, and for sure, I did that for a while too. And that's actually what we're doing right now, is actually going through the routing process, which is kind of nuts. And actually wiring up this ultimately will be this printed circuit board that will represent. Here's the old version of it. This is the Brew Buddy, and I'm going to create a new version with new hardware. So that's what we're working on right now. And so right now what I'm trying to do is actually create a via from the bottom to the top of the board, which is a little bit, it's giving me fits for some silly reason. And that brings y'all up to date. It's like off a little bit. I gotta move it. All right. Oh, you know what? I'm being silly. If I switch back to the top layer, I should get a via. I should get a via here automatically. No. All right, let's come back to that and do some more routing here right now. So dev chat folks, how was the rest of the stream? I jumped on a little bit before I had to get into meetings, but Brendan, you were entertaining as always. And for the dev chat folks, if this is your first time, I actually did dye my hair blue in honor of reaching 100 followers on Twitch last week. Oh, and thanks folks for the follow. I'm missing. All my alerts are like broken right now. Who am I missing? Fixer Jake 14 and goddamn, I love Myrtle Beach. I love your name. I have never been, but I have family that are big fans. Big fans. That's great. Good streams. I'm glad. That's fun. Let me switch back to my main here. Oh yes. I like that. Is that the table flip emoticon? I haven't seen that one yet. I'm gonna have to use that. I actually have myself a table flip video that my Stream Deck will pull up for me automatically if I ever get to a point where Reclock Codes is now follow. Okay, now the alerts are happening again. Thank you for the follow. So I added myself a little table. This, when I do software streams, I use this a lot because this is most of my Tetrix. Thanks for the follow. Awesome. I appreciate it. Table flip feels appropriate right now, given that I can't get these vias to work. But hey, that's all right. So I'm going to come back around. So the next piece, and I mentioned before, these yellow lines for folks that haven't done PCB layout before, or if you've thought about it, the yellow lines are basically telling me where I need to route things. They're giving me sort of guidelines to say, hey, you need to actually electrically connect these pieces here on the PCB. These pin mappings I define first in the firmware, and as I showed earlier, this jumper wire prototypey business was what we got working last week. So now it's time to do the fun of creating this custom PCB and wiring things up, and then I'm going to order it online, and should actually have it on hand in the course of the next week, which should be kind of fun. So I'm going to go ahead and wire up ground here. Soul Penner, thank you for the follow. I appreciate it very, very much. All right, and I'm going to stay on top here. So this one should be pretty straightforward. I'm just going to connect there. So that's good. Maybe, there we go. Not totally necessary to go that far out. And then next up, we'll connect to power here. Nope. So what did y'all manage to get done? What did y'all manage to get done on the Dev Chatter stream today? See, I can see that now. Yes, there we go. As y'all watch me sort of get anal retentive about laying these things out here. So the next one I'm gonna lay out here is the There we go, DC. Should be pretty straightforward. Keeping these kind of close. I like that. Finicky. Pulled EF core from our app. Except for identity. Okay. So what did you, are you switching to something else? Ah, Dapper. Very nice. Boy, I haven't used Entity Framework in a long, long time. And I have heard good things about Dapper. Was it pretty easy to actually get through setting up Dapper? Come on, come on. Fluent migrating instead of ES core migrations. That's awesome. Okay, I'm getting down to like the really, these are things that bother me about layout. Okay. That looks nice. Oh, you did the Dapper setup already. Okay. Okay. So here is another place where we're gonna need to use a, we'll come back to that one. I'm gonna save the tricky routes for later. Today was remove EF core. I bet that felt pretty good though. Luke Streams 04, thanks so much for the follow. I appreciate it. Hope you're having a good Tuesday. Did I really have a good Tuesday? It's taken me most of today to even remember that it's actually Tuesday. I had yesterday off, which was nice to spend some time with the kids. And it was good fun. All right. I think, y'all forgive me for a second. I'm trying to wrap my head around what I want to do here next. This is the part that gets just, it's not tedious. It's just, it's tedious. Okay, let's be honest with one another. It's just tedious. But this is the part of layout. I mean, this is the reality of it. Babbitt, you said earlier you've done auto routing, and I mean this is usually why it makes, I feel like a lot of times I follow. You know, I do the same thing. I like to get this done quickly. Auto routing definitely gets you there. But it's kind of fun sometimes. This is what this ends up becoming, honestly. And I'm seeing as I'm kind of blocked a little bit here. This is sort of like a little bit of a puzzle, right? I'm trying to sort of work through, my constraints are that I can't actually have wires of the same color cross. I can't cross certain dimensions, like these white circles here represent holes in the board, so I can't go through those areas. So it ends up becoming a bit of a puzzle of what are the shortest lines that I can put between the pieces on this board that doesn't violate any rules. And I can run DRC to actually see what sort of issues I have. Right now it's just I still have 9 air wires, that's expected. I don't have any other potential issues right now. But if I tried to run a wire, for instance, let's actually start this next one. If I tried to run a wire through this hole here, it's actually not going to let me because the tools are smart enough to keep me from doing that. But you'll notice that it actually gets kind of crazy with moving the lines around because it's trying to keep me from doing anything stupid that I will later regret. So this MOSI connection is coming from around, here's what I'm going to do. I don't love that. Not that. Oh, actually, I guess I can just do it right here. Oh, that's nasty looking. So anyway, in the pursuit of solving this puzzle, I am going to see if I can connect some things up. And let's just do a couple more easy ones. So that will go there. My miso, I'll go up and over, but I'll bring it down here and follow a similar path. Cool. So yeah, most of the time for folks that are new here, most of my time I actually do write code and do hardware stuff on the streams. This was sort of a chance to do something slightly different. Hopefully, even if this isn't up your alley, you're enjoying watching something a little bit different, using tools to do layout. My Thursday streams are exclusively code writing. So what I'll be doing on Thursday is actually getting back to the prototyping board here. And messing with adding some extra functionality to that, and I'll be writing the code for that in VS Code, because I love VS Code. Everybody loves VS Code. So definitely keep on hanging out today. Feel free, and if you're interested in the code side of things, definitely join me again on Thursdays. I'll keep on working on that. So I have a miso connection on the other side that I'll go ahead. I mean, it's fine. All right. So how many do I have left here? We run the DRC again. It tells me I have 6. 6 more to go. Throw that up there. All right. See if there's any easy ones. Oh yes, there is still my... Okay, so now I'm in a weird situation with this one, where I'm going to have to start up top. And that's okay. What is this? Yeah, forgive me. So what I'm trying to do right now is actually run a via. A via is just a plated copper hole that allows me to run copper wires from one side of a printed circuit board to the other. So that allows me to avoid conflicts. Like right now, this PCB or this header piece is only on the top of the board. So I have a lot more options at my disposal if I run a wire to the bottom, which is what I'm doing, this blue wire here. But for some reason today, Eagle, which is the computer-aided design layout software that I'm using to build this PCB, is being finicky. And it's not letting me run vias in an easy, sort of clean way. Overlap. I know there's an overlap. I want there to be an overlap. Trying to run a via. The software, Eagle, has been updated recently. And I'm really just wondering if I'm doing something wrong. All right, so hold on here. The width of my wires, 2.032. So my via drills should be 2. They're 5.5. So if I am removing, let me remove this via. If I go to the bottom, which is where my blue bars are, I should. Oh, have they? Surely they didn't change the way that this worked. Drill. 0.2. This is really ticking me off. So, yeah, Babbitt, you're asking, is it complaining because the trace isn't actually connected to the via? To be completely honest, I'm not 100% certain why it's complaining right now. Other than the fact that maybe it actually is wanting me to put the via in first, which is a bit ridiculous. But I can do it if I have to. See, it's not even letting me route to the via, so I have no idea what's going on with this right now. They have changed the way that vias work in Eagle, I think. And I'm tearing my head out right now. Where's that table flip thing? Do that again. Same thing. While I search for... I swear they changed it. So I need something like... Reclaw codes, yes. I hate it when software stuff changes out from under you. And the problem with Eagle is the Eagle has been around. Look at this. There's a video on doing vias in Eagle that's from 2008. Over 10 years ago. It's not going to help me. The tool has changed so much. I mean, SparkFun has some tutorials on this, you know, but these are going to be kind of old as well. I mean, all right, so you see what's happening in this animated GIF here? This is what I'm trying to do. Several years ago, that's exactly right. I was a much younger individual. This is what I'm trying to do right now. This is a very, very simple thing. Click to via. Left click in the black to glue your trace down, then you can either change manually or click your middle mouse button to swap sides. I mean, there's a chance that I'm listening, but also working, so I can't always watch it. Can I see you place the via? Oh yeah, no problem. Don't worry about it, Babbitt. I am a big Twitch multi-tasker myself, so don't even worry about it. So if I no, all right. So if I'm routing a little bit more. It's not. So that right-clicking here is just going to change the line style. There we go. That was it. That was it. I just have to click the right button on the mouse. The other approach, I'm not even. It should work. It really should absolutely work. It should not be an issue. But hey, you know, it's all right. Okay. I don't like that this has now gone like weird on me though. Oh, it changed to S curves. That's what it is. All right, hold on. Okay. I'm trying to figure out which button I pushed before. It's a bit frustrating when things like this change, Tool Printer. You're absolutely right. It very, very much is. And it's something that I have used so many times, and I'm at a loss for why this is doing this to me again, even. Well, like I just had it. There we go. So I gotta click my... I mentioned this earlier, but I switched to a new mouse, or switched to a new mouse and keyboard over the weekend, and it's a wheel mouse now. And that's ultimately what my... All right, so here, click again, back to 1. No, no, no. No, no, what? Here, connect them up this way. All right, so click. Click, bottom. All right, it's not letting me place the via there, which means I probably need to move this one. Yeah. All right, so this should give me a little bit more freedom now. Okay, I'll deal with that one in a second. Move this one back. And I think that is a good spot for my via. That's just like automatically doing it? That's not... Oh, Eagle. Killing me, Smalls. I'm going to rip up this entire thing and assume that I can figure it out from the other way. So switch back to my bottom layer, and I will route like a happy person to here. And you know what I'm going to do? I'm just going to go ahead and go straight in through the bottom and rip this up. Not that one. So I'll come around the other way on that one, come down from the bottom. And now we get this done. So okay, top. There we go. Now we're in business. Okay. Getting the hang of the way they changed doing vias. Excuse me. So now we only have four left, right? So that's not bad. And we're going to need to do some more vias here. So let's start here with this one. And I'm going to plan this out appropriately. Yeah, I'm going to do my via as close to... All right, let me think this through. Because I have a few different... Actually, I can take that one all the way on the bottom. Yeah, let's do TFT reset first. All right. So because these are all surface mount components, I have to come kind of through the other side here. So that one's kind of close. To go back to the top. Ah, I did it to myself again. Come on. There we go. All right. 2 left, 3 left. No, 2. 3. I'm going crazy. So that was reset. Now we have chip select. It looks like I can actually just go straight on that one. Yeah. The other one will have to come to the bottom. But so now what I need to think about, because these 2 lines are crossing, I need to think carefully about how this is going to work. If I start here, kind of come over this way. Just got here, so this is for a display. Yeah, crazy old gamer. Hey, thanks. Thanks for jumping in and commenting. I appreciate it. Yeah. So this I just switched. So this is the Brew Buddy. This is a custom electronics project that I that I'm modernizing, that I'm putting on some new hardware. It runs on a temperature sensor. It actually keeps track of home brewing, keeps track of beer temperature. There's some fermentation sensors on there too with the little piezo. And right now everything is breadboarded and wired up with all kinds of crazy jumper wires. But there is a display in here as well, a 2.2-inch TFT. This is the old version of the printed circuit board that I created for this. And what I did last week was actually put this on new hardware. And what's happening now is I am actually taking the breadboard equivalent of this and creating a new printed circuit board for this right now. So what I am wiring up over here is ultimately going to be the new iteration of this PCB, which will have the display on it and the sensors and everything. I missed that was for homebrewing. That's a hobby I've always wanted to get into. Oh, yeah. Sorry, Rick. Yeah, I should have mentioned that again. But yeah, this is it's something that I've been doing for homebrewing. I would say probably 6-7 years now. It's been a little while since I've done it. I actually created this project the first time, created this board and everything about 3 years ago. And I'm sort of just now getting around to modernizing it, putting on new hardware, all that crazy stuff. So, and it's fun. Rick Lacotes, if you ever really seriously think about it, and I live in Austin, Texas, and there's an amazing homebrew supply place nearby called Austin Homebrew Supply, naturally. And you can actually go and get starter kits that have like really everything you need to brew your first batch of beer. And it's a lot of fun. It's pretty addicting after that. Not the beer itself, the brewing process. Cool. Oh, thanks. What am I making the PCB with? So I will actually be using a service called OshPark. There are a number of great ones out there. OshPark is one of my favorites. They're an inexpensive service. PCBWay, actually, they show up as the first ad on Google. I've used PCBWay as well for boards that I have done in the past, but for this one, I'm going to use OshPark. That's the plan. What I'm going to order today when I'm done actually spinning this over. And yeah, Austin is great. I love being here. I've been here for almost 10 years now. But I came from Colorado, and I do miss Colorado a lot, especially in the wintertime with the skiing. I don't miss the snow, but I definitely miss getting on the skiing part. That was always fun. All right, I'm gonna I'm just going to bite the bullet and go here. Why is it doing that? Why is it doing that? Oh, come on. Oh, I did it to myself again. Messed up the lines. Oh, it looks like a lambda. Okay. What kind of beer am I brewing? Good question, Stoolpinner. Am I going to give you like the most Austin hipster answer of all time? But I actually do really like IPAs. Sue me. I always kind of have. Always been a big fan. IPAs and Imperial Stouts are two of my absolute favorites. The problem with both of those is that they are not low in alcohol content, so gotta be kind of careful with them. I like your addressable LEDs back there. Is that an Arduino project? Thanks, Crazy Old Gamer. Kind of. So I actually, is that a thumbs up on the Imperial Stout? Seems good. Oh yes, yes, definitely. These are actually, I have 4 NeoPixel strips on the wall here behind me, and that will actually be featured on a future stream very soon. I actually want to make those Twitch chat controllable. But they're actually running Arduino style microcontrollers from the company I work for, Particle. So if you go to, they're actually running on a board called the Particle Argon. So if you go to particle.io, I'll do the shameless plug for just a second. Since you asked, we create cellular, Wi-Fi, and mesh-based connectivity hardware, and then platform services. And for Wi-Fi, we actually have there's a few different boards, but the Argon is the board that I'm using here for this project for the Brew Buddy. And then the Xenon is a mesh-only board. I actually can do 802.15.4 mesh networking. So that's pretty sweet. But yeah, so they are, these devices are programmable with Arduino or wiring C. So they work in a very similar way to other devices, Arduino devices, Adafruit devices, things like that. All right, I was going to move this up a little bit so that I can actually put the... Oh, man, I did it again. Hold on. Okay. What just happened? No. Sure. Okay. Yeah, for those of you that just jumped on, I discovered that Eagle is ticking me off today with some of the things that they did to change the way that you do vias to run routes between the bottoms and the tops of boards. So I'm trying to get this done. Okay, so we're now down on the very last wire. I will do a little outline and then throw this into Osh Park so that y'all can see. And I think that will be the end. That'll be how we wrap up the stream. So this will be the challenging one because you'll notice I have to go over both blue and red. So I got to go across top and bottom here. I'm going to start on the bottom because it looks like I can get most of the way there doing that. And then I'm going to go actually... There we go. I'm going to go around my other via here. King Recycle, thanks so much for the follow. Appreciate it. Welcome. Thanks for hanging out. We're here today building a custom PCB for an electronics project that I've been working on for a little while. So come down here. Crazy Old Gamer, what's on pin 2 and 3? Are you referring to the... What are you referring to? I'll show you the schematic really quick so you can get a better idea of what's actually happening here. In the center is the particle argon, so this is actually the main microcontroller here for the board. And then everything else here is a piezo buzzer that'll function as a knock sensor to detect when fermentation starts. This is the Adafruit 2.2-inch TFT, and then a 6-pin Type K thermocouple, which is a, I'll pull up the camera on that so you can see it. That's actually a little food grade thermometer that actually goes in the wort and will tell me what temperature my beer is at while it's brewing. Bit of a vanity metric when you're doing things like doing the initial boil and things like that, because I also have an analog thermometer that I put in there. But that can be especially useful when I'm going through the cooling off process after fermentation is done. Typically what you want to do is you want to get the beer from its very high boiling temperature down to room temperature as quickly as possible. People have a couple of different ways to do that. A lot of homebrewers use ice baths. What a lot of people will do also, and what I use, is something called a wort chiller, which is a brass tube that you put inside the wort, and then you run water through the inside of the tube, and that'll actually get it down a lot faster. But I am tracking that temperature curve as it comes down on the TFT, and then also posting that online so that I can keep track of how quickly the beer actually cools down. So. Oh, 2 and 3 or 3 volt. That's what you're asking about. See, I answered the wrong question. Yes, yeah. Pin 2 is 3 volt. Pin 3 is just a on the Argon itself. Let me pull up the data sheet for that. 3 is a mode pin. It's used for something else entirely different. 2 is 3 volt. You also have LiPo and V-bus if you're using USB power, like if you need 5 volts directly to you're powering from USB, but you need 5 volts on something, as opposed to just the 3.3 volts that comes out of the device. All right, so now it's time to add some dimension lines. This is the fun part because I'm actually going to get a bit of a sketch of my board. So I'm going to choose line, and I'm going to choose dimension, and we will just start drawing this. That's messy. I'm going to switch to right angles for this piece. And we'll move some lines in. So that's that. And you'll notice when I actually create a square, oh, hold on, I gotta move. Some of my wires are outside of the board. So I now have, I got a light gray outside of the board and a black inside, which means that there is actually an outline for the board now. So I can open up the manufacturing view and see exactly what the thing is gonna look like. And zoom in a little bit to see what the top looks like. You can see the wires underneath, or the traces underneath. You can take a look at the bottom side as well. Vias, holes, those kinds of things. Few last things that I want to do is actually move up some of my text. It was on here before. Move this to the bottom, change that text. And then it looks like C# Fritz just went online, so when I am done here in just a minute, I'm going to raid over to him. So if you want to hang tight, Although feel free to jump over there already if you wish. And then I have the last piece are the holes. Move these up, and then I got to zoom back in. I don't know why I can't. And we'll just do arbitrary placement for now. I'll clean this up later, but I just kind of want to show y'all more programmers. That's hardly science. I mean, this programming is more of an art form, right? Right. So now that I have this in sort of a nice, let me zoom in here so y'all can see it. This is our board. This is what we've managed to craft and create over the course of the last couple of hours. I can run my design rule check on this to see no boxes come up. Everything looks good. So this is actually ready for me to order, to go ahead and make happen. So the way that OshPark works is you can actually just browse for a .brd file directly, which is the board format that that Eagle uses. So if I go into hardware and then I go into .brd and then click open, and say uploading your design, and I can get, this will actually take just a moment to process. Hopefully it won't give me any errors. I can show y'all what's going to happen here. And all right, great. So it's giving me an idea here. Non-critical error, your project doesn't contain a bottom silk screen, but it shows, look, 2-layer board, 2.7 inches by 2.85. It'll cost me $38. That's not great. I can make it a little bit smaller, and I'll go ahead and do that. But it does give you sort of that quick idea of what's happening on your board and how much it's going to cost. So this is great. I have the board laid out. Things are working. Now it's just a matter of tweaking, getting things where I like them, and we're going to go ahead and do that. So I'm going to continue with this on Thursday. I'm going to continue on the firmware side of things. So thank you all so much for joining me today. We're going to raid over to Mr. C# Fritz. So please definitely hang for just a second, and we will head that way. Thank you all again for hanging out today. Again, I said we'll continue this on Thursday, and talk to you again soon. Take care.